This is a video to recall with you lesson 2.3 polynomial identities. I just want to say this video most probably is going to be a bit long because we have around 4 ideas, but like the first two, they have two main things to cover. We have a lot to discuss, but please don't rely on this video to study for the final. You have to, of course, solve questions from the book or pack I prepared for you and practice enough. Ask me at any time. Please reach out if you need any help, any assist. If you have any question at any point, just ask me. Okay, I'll start off with the first idea. In the first idea, we deal with power of 2, basically, squares, or a square of binomial difference of squares. So we have two identities, one of them to factor and the other one to expand or multiply. Basically, the first one to factor or to expand if you have the other way. Anyways, so the first one, if you have two terms squared and there's a subtraction between them, you can factor them as, factor means multiply, write them as something times something, okay? You can factor them as the first term without the power plus the second term, of course, without the power, and then times the first term minus the second term. So you write them as sum and difference of two binomials. So let's say, for example, here I can see clearly that this is the first term squared, and of course I'm going to use this property. The second term is not squared. Can I rewrite it as something squared? You can check using the calculator. You can just go ahead and do square root of the 25. The answer is 5, so I can write it as 5 squared, because if you try to do 5 squared in the calculator, you're going to get 25. So instead of 25, I will replace it with 5 squared. Just rewrite it. Minus x squared. Why did I do that? So I can see my a and b clearly, and I can use the property. Okay? Now I can see clearly that my a is x, my b is 5. So this is going to be very helpful to factor. So basically from here, I can rewrite this as, I know it's a plus b, a minus b, but I'm going to use my a, which is x, plus my b, which is 5. The other term is going to be also x minus 5. One of them addition, one of them subtraction. Okay? So this is a very nice and easy property you can do. Or we have one more property, which is square of a sum. You have also a and b, but both of them are squared, not separately. How can we expand? How can we square them? Like, how can we evaluate this thing? You can use FOIL method if you want, or just use this property. How does it work? Of course, you have to memorize the property, and it works for addition and it works for subtraction. If you have subtraction, you do have a property. It's not written, but there is a property for subtraction, but the term in the middle is minus 2ab. The rest are all the same. So for addition, this is how it looks like. For subtraction, it's the same, but the term in the middle have a subtraction. But for difference of squares, it works only for subtraction of 2 squares. That's it. It's just subtraction of 2 squares. Bas. طيب, how does it work for this property? You should have 2 terms and both of them are squared within a bracket. It's very clear. It's so different. How does it work? You take the first term. First of all, you have to know that your a is your first term, which is x. Your b is your second term, which is 7. And then use the property. What's the property? A squared plus, since it's addition, so just use plus, 2ab plus b squared. Now, instead of every a and b, substitute with your a and b. My a is x, so just substitute within a bracket, plus 2 times your a times your b. My b is 7. Plus b squared is, my b is basically 7. Then evaluate. How do we evaluate this one? X squared, just x squared. Plus 2 times 7, multiply the numbers. 2 times 7 is 14, and put the variable down. Plus 7 squared is 49. That's it. This is how you do it. Okay? Now sometimes I might give you different way of asking about the same concept. So suppose that I won't give you the factored, squares, difference of squares. Suppose that I gave you the factors and I ask you to multiply or evaluate how much does it equal to. So you can use it both sides, like both ways. So for example, if you have something like this, I can see clearly that this is the answer of which property? Of this property. A squared minus b squared equals a plus b times a minus b. But my a is x, my b is 2. I can see that clearly. So in order to evaluate this or to multiply this, to expand, I don't have to use FOIL method. I know this is just the same as this property. So directly the answer will equal to what? The first term squared, the second term squared, and there's a subtraction between them, not addition. So the first term is basically x, square it, minus the second term is basically 2, take it without a sign, square it. Remember, the signs are already something that is done within the property. And then just simplify. X squared is x squared, 2 squared is 4. That's it. This is a very easy way to evaluate it. Let's try to see how can we do it here. Okay? So again, this is my A, this is my B. And the whole thing is A and B because it's just the same as the answer of this property. I want to get back to the property. How does it work? Just identify your A and B and then write down your answer. It should be a squared minus b squared. So my answer should look like this: a squared minus b squared. Substitute. What's your A? It's 3x squared. All of it should be squared and use a bracket for that. Minus your b squared. What's my b? It's 5y cubed. Then evaluate like how much is it going to be squared. So how do we do that? You have two options. Either multiply this term by itself, يعني take it on the side, 3x squared times 3x squared, and then multiply 3 times 3 is 9. X squared times x squared is x to the power of 4. You can do that. Or just square the 3, it's going to be 9. Square the x squared, just multiply the powers, it's going to be 4, x to the power of 4. Okay? Minus. Same here. Square the 5, it's going to be, square the 5, not multiply it by 2. It's going to be 25. Square the y cubed. Square the y cubed means like multiply 3 times this one. Or, it's going to be y to the power of 6. Or, as I said, take it on the side. 5 to the power of 3 times 5 to the power y to the power of 3. 5 times 5 is 25. Y to the power of 3 times y to the power of 3, just add the powers. So you either add the powers by multiplying it by itself, or multiply the powers by distributing the square. Okay? You have both ways to do it. Just make sure you know how to do each one separately. A common mistake students might do, they might add the 3 with the 2. La. You either multiply the power 2 with the 3 or add the 3 with itself. Okay? Add the 3 with the 3. طيب. This is the answer. So we are working on the same property again, but here I'm asking you about opposite way around. I gave you the answer, give me back how it was. طيب. Let's do this question again. Looking at this question, I can see that this is a 9, and I know that the 9 is the answer of squaring a number, right? So from the 9, I know that I have to use the property of a squared minus b squared. And also the subtraction is another sign that it can work, okay? So let's see. First of all, I have to write this one as something squared. How does it work? The 8, break it down as 2 times something. I know the 8 is basically 2 times 4. Keep the 4 inside and keep the 2 outside. So it's going to be m to the power of 4. Inside is the 4. And outside is the 2, because I want it to be something squared. Okay? So it was 8. I broke it down into 2 powers. Same as here. it was 2 powers. I multiplied them to get the answer or the final power. But here I have the final power and I broke them into 2 powers. Okay, if you multiply them, you're gonna get back the 8. Anyways, all of this to rewrite it as a squared, a term squared, minus another term squared. Okay? And remember, a can be anything, not only m or x or y or 4, or it can be any term. It can be this whole thing. This whole thing is b. This whole thing is a. So it can be anything. Anyways, now when it comes to here, again, break down the n into the 10 to 2 powers. One of them must be 2, so I can get the squared. So ask yourself, 2 times what will give me 10? 2 times 5. The 5 keep it inside, the 2 keep it outside. Okay? So the n now is 5 times 2. Now coming to the 9, I don't want the 9 to stay like this. I want the 9 to be also squared so I can let it be inside the powers. So how can I rewrite the 9 as something squared? Just take the square root of 9. Square root of 9 is basically 3. So rewrite the 9 as, instead of the 9, just write it as 3 squared, but the squared is also outside, so no need to write the squared. Khalas. So instead of doing 3 squared and n to the power of 5 squared, just write it quickly, 3n to the power of 5, both of them squared one time, and that's it. This is a better way because I want one term squared. Okay? So how can we rewrite any term? Think about the power as 2 times something, and if you have a number, just square root it. Write the answer of square root inside and write the power left inside of squared. Okay? Now here I can see clearly that this is my A, this is my B. Khalas, on the side state, write down that my A is m to the power of 4. My B is 3n to the power of 5. Okay, you have to always remind yourself with your A and B. Now, what's the answer of squares, difference of squares? The first term plus the second term without a power times the first term minus the second term. You need to memorize the rule. So take the first term as it is without the power. Khalas. Take only the first term. So m to the power of 4. But miss, you said without the power. Yeah, I said without the 2, power of 2. But keep power of 4. It belongs to your A. This is your A now. عادي. Tamam. First term plus second term. See, I did not write power of 2. Times first term minus second term. This lesson you have to practice a lot. Like I think this video is going to be like really long, but you need to practice yourself. Okay? Type. Same thing here. I'll go through it step by step. Once you see any number, try to find the square root of it, because like if you want to write it as something squared, you have to find the square root of it. So the 4, take a square root of 4, it's going to be 2 squared. Take a square root of 49, it's going to be 7 squared. So instead of 49, I'm writing 7 squared. But what about 4x to the power of 4? Again, x to the power of 4, I can't accept this. It should be power of 2. So break the 4 into 2 times something. So 2 times what will give me 4? 2 times 2. One of them keep it inside, one of them outside. So just extend this bracket. Khalas. Now what do you have? 2 squared for the 4, right? Done. And instead of x to the power of 4, I'm going to have x to the power of 2 and outside 2. This instead of x to the power of 4. Why? Because 2 times 2 is 4. Okay? So just write inside x to the power of 2 and outside there is already power of 2. Always make sure that you only have power of 2 one time outside and you don't have 2 to the power of 2 and like many powers. Okay? If you don't like to do it at one time, just do it at multiple steps. No problem. Add. 4 is basically 2 to the power of 2 on the side. X to the power of 4 is basically x to the power of 2 to the power of 2. And then put them together under one power. It's going to be 2 x to the power of 2 and both are to the power of 2. No need to do them power of 2 separately. Okay. Now I can see clearly that I have this as my A and this one as my B. They look like A squared minus B squared. So use the property. What does the property say? Again, on the side state that my A is 2x squared. My B is 7 only. The property says A plus B times A minus B. So what's your A? It's 2x squared plus. What's your B? It's 7. What's your A? It's 2x squared minus. What's your B? It's 7. That's it. You need to practice for this lesson. It's not that easy, but you have to practice. Especially the steps of factorization. How to rewrite the terms as something squared, something. This is the tricky part. The rest is easy. طيب. This one, I don't have it as A squared plus B squared, or I don't have a property for this أصلا. What do I have it as? I have it as two terms, both of them are squared. This reminds me of this property, right? You have to memorize it. It's basically A plus B, both squared, equals the first term squared plus 2 times the first term times the second term plus second term squared. This is for addition. For subtraction, it's very similar. Two terms subtracted. How does it work? First term squared minus 2 times first term times second term plus b squared. Remember, if you have a subtraction, only the 2 times something will be negative. If you have addition, everything will be positive. طيب, how does it work? Identify your A and identify your B. This is my A, this is my B. Take the B without the sign. Take the A without the sign. So your A is x, your B is 2. Remember, the sign is already something that was done within the property. خلاص. That's why they changed it here. تمام? So how does the answer look like? A squared plus 2ab plus b squared. So instead of every a and b, substitute. A is x, so x squared. Always substitute using a bracket. Plus 2 times, the a is x, the b is 2, plus the b is 2 squared. And then evaluate. X squared is just x squared. Thus, 2 times 2 is 4. Put the x down. Plus 2 squared is 4. That's it. This is the answer. This is an easy property, to be honest. Here, my A is 3x. My B is 4 only. Ignore the sign. Why do we have to ignore it? Because you're gonna already write it within the property. It's written. A squared minus, the sign went directly here. خلاص. 2ab plus b squared. تمام? Don't forget that it's subtraction, therefore I have to put a sign here. Okay? Only here within the 2ab. Type. Substitute your a. It's basically 3x squared. I have to square it, all of it. Minus 2 times. My a is 3x. My b is 4. Plus your b is 4. Just square it. Now, how does it work here? You either can do 3x squared is basically 3x times 3x. And the side multiply. 3 times 3 is 9. X times x is x squared. You can do that. Or square the 3, it's 9. Square the x, it's x squared. Both ways works. Minus 2 times 3. Multiply the numbers only. 2 times 3 times 4. If you multiply these in the calculator, you're going to get 24. Put the x down. Then 4 squared is basically 16. That's it. This is the final answer. This property is an easy property. I feel like the only tricky part is this one. You have to make sure you understand how to rewrite the terms. So, we are done with anything to the power of 2. We are done with both properties. A squared minus b squared is basically the difference and sum of AB. This one we're done with it. And we are also done with 2 more properties, which are a plus b squared or a minus b squared. How do we evaluate them? First term squared plus, if it was addition, it's plus 2ab plus second term squared. If it was subtraction, it's going to be first term squared minus 2ab plus b squared. Okay, fine. Now let's move to the second idea, which is difference of cubes and sum of cubes. So these two properties also you have to memorize them. I know they are like you have a lot of properties now to memorize, and these ones are a bit longer than the previous ones, but with practice it's going to be easier for you to recall these properties. Okay, how does it work? So these properties is to factorize, nothing to multiply here. So I will give you two terms cubed, either subtracted, or two terms, both of each one is cubed and added. How do you factorize? You write the first term. If it was subtraction, you write the first term minus second term in one bracket. And the other bracket, you write the first term squared plus first times second plus second term squared. You have to memorize it. You can't do it any other way. You need to memorize how to factor it. Okay? Both properties, they work within something. First term cubed minus second term cubed, or first term cubed plus second term cubed. I just want to say something. The previous property squared, when we have something squared minus another thing squared, we do not have a property for two terms squared and they are added. There is no such a property. Nothing to factor this. You can't factor this, the addition of two squared, so you only have subtraction case. But for cubes, you have a subtraction and you have addition. Okay? You have to clearly distinguish between them. Okay? Fine. So let's see. For example, here I see clearly that I have power of 3, so I definitely have to use this property, not the previous one. You will see directly, because of power of 3 or anything to the power of 3 or anything I can use cube root for it, you will see that you can use this property. Let's try to factor this one using the property of two terms cubed and there's a subtraction between them. Before you start, remember you have to identify what's your A and what's your B. Clearly I can see that my A is only X because it's the only term cubed. Tamam? Remember, we take the A without the cubed. Hello? What's your B? I have to rewrite this as something cubed and this thing will be the B. So how do we do that? Again, use your calculator. If you want to find this number, where is it? Just use cube root, not square root, cube root, because it should be cubed. So in the calculator, there is a cube root. Make sure you're using cube root and write down 64. You will get, if you try to find that out, you're gonna get 4. So the 4 to the power of 3, you can double check. Try to do 4 to the power of 3, it's gonna give you back the 64, okay? 4 to the power of 3 is the 64, and x to the power of 3 is already written as something to the power of 3. This is your A and this is your B. You can see that clearly. Just make sure they are written separately as something to the power of 3. And then write down your property. My property should be, we should write the answer as first term minus second term times first term squared plus first times second plus second term squared. Okay? And then plug in your A and B. My A is X minus my B is 4. The A is X, so X squared is X squared, plus the A is X, the B is 4, so 4 times X is 4X, plus the B is 4, but square it is going to be 16. This is the final answer. You have to be careful while dealing with properties of this lesson. Okay, same thing here. I can see clearly that this is the A, so the A is X, and the B I cannot really see that clearly. I have to rewrite the 125 as something to the power of 3. I already have the X as X to the power of 3. Okay, there's an addition between them, so I have to use this property. How do you find what's that number? Just use root 3 of 125. It's going to be 5. You can double check. Try to do 5 to the power of 3 Is it 125? It will be 125. Okay? So your b is basically 5. Now write down your answer. The answer should be a, because it's addition, I start with addition. And the other bracket will be a squared minus, here's the subtraction, ab plus b squared. Okay? So your a is what? It's x, plus your b is what? It's 5. Then a is x, so square it, it's gonna be x squared minus x times a is x, b is 5, so x times 5 is 5x, plus b is 5, just square it, it's gonna be 25. And that's the answer. That's it. Okay? Let's take, for example, this one. Type, how do we work with such questions? Again, I feel like this is for the previous property. I'll get back to this later. I'll do this one, okay? So here I can see clearly that this is my A, and here I cannot see the B clearly, so I have to rewrite it as the B. How do we do that? Just use cube root of 216, okay? So if you use cube root of 216, you're gonna get 6. So I can write the 216 as 6 to the power of 3. Double check. Try to do 6 to the power of 3. On your calculator, you're supposed to get 216. Okay? Anyways, this is already written as x to the power of 3, so done. My a is clearly x. My b is clearly 6. Because there's a subtraction between them, I will do a minus b first, then a squared plus ab plus b squared, and then plug in your ab. First write the rule, then plug in your variables, the values that you have as a and b. The a is x minus the b is 6 times the a is x squared, because we have to write it as a squared, plus a is x, b is 6, so 6 times x is 6x, plus 6 squared is 36. This is the answer. Okay. I want to do a question instead of this one, because this is for the previous property. I'll do, let's try to do this one. 8x to the power of 6 minus y to the power of 3. So let's try to do this one. I can see clearly from here that this is my b. It's directly ready. It's something cubed. But here it's not ready. I have to rewrite the 8 as something to the power of 3. And I have to rewrite the x to the power of 6 as something to the power of 3. Okay? How do we do that? The 8 is easy. Just use cube root of 8. You're going to get 2. So write that down as 2 to the power of 3. But for the x to the power of 6, remember, break down the 6 as 3 times something, because I want it to be power of 3. Okay? How do I decide that it should be power of 3 outside? Because this was already written as power of 3. Then I know that I have to use this property. Okay? So everything should be written as something to the power of 3. This is done. This one, it's basically 3 times 2. So keep x to the power of 2 inside and x to the power of 3 outside. Double check. How do we double check? 2 times 3, it will give you back 6. Minus y to the power of 3. This is your b, it's clear. But for your a, you still have to rearrange this. It should be something to the power of 3. So power of 3, just pull it out. And everything else, write it down. 2x squared. Okay? Minus y to the power of 3. This is your b. And this is your a. See? There's a subtraction between them, so it should be what? It should look like this property. A minus b times a squared plus ab plus b squared. Yeah. A is 2x squared minus b is y times a is 2x squared. You have to square it. So on the side, just do 2x squared, I have to square it. Square the 2, it's going to be 4. Square x squared, it's going to be x to the power of 4. So write it down. 4x to the power of 4 plus ab. So a times b. Your a is 2x cubed, or 2x squared, times your b is y. So the answer is 2x squared y. Add. Your b should be squared, so just y squared. That's it. This was the only tricky part, okay? And that's the final answer here. Okay. Now, let's take one more example. Instead of this question, you can do that, that's easy. But let's take, for example, I'm trying to give you some challenging questions so you guys can have an idea. Let's take, for example, this one. M to the power of 9 plus 27 n to the power of 6. This is like the hardest maybe possible way of having a question. So how can we do such a question? Basically, first of all, I can see clearly that there's an addition, so it's definitely the rule of a cubed plus b cubed. Remember, we have the following rules so far. A cubed minus b cubed is 2 brackets, one of them is small, one of them is big. A minus b, and the second one, a squared plus ab without a 2 plus b squared. And if you have a cubed plus b cubed equals a plus b, then the second one, a squared minus ab plus b squared. These are for the cubes. Factoring. For squaring, factoring squares, you have a squared minus b squared, and how does it work? A minus b times a plus b. And for a squared plus b squared, we don't have a rule. No rule. You cannot factor it. This is for squares. Okay? So when I see an addition between two terms that they have powers, directly I will know definitely it's this one. This is the only one with addition. Tamam? So you have to make sure to write it as a cubed plus b cubed. Okay? So this one is not cubed. I have to write it as something, okay, to the power of 3. And this one is not cubed. I have to write it as also something to the power of 3. How does it work? First of all, remember, just break down the power as something times something. So break it as 3 times something so that you have power of 3 as one of them. I know that 3 times 3 is 9, so keep 3 outside and 1 3 inside. And just keep the base m. Now double check, 3 times 3 will give you 9 and m will be there. For this case, when you have a number and a variable, start with the variable, break down the power of 6 into 3 times something, because I want power of 3 to be outside. So 3 times 2 is basically 6. So now you have it as n to the power of 2 to the power of 3. So 3 times 2 will give you back the 6. Done. Now the 27, just find cube root and always use cube because we're breaking down into power of 3. Cube root of 27. If you try to evaluate how much is cube root of 27, you're going to get 3. So just try to do cube root of 27. It's basically 3. So I can say that 3 to the power of 3 is 27. You can double check this fact in the calculator. So instead of writing 3 to the power of 3 is already outside. Just write 3 inside. Okay? Because 3 to the power of 3 is 27. 3 to the 3 times the 2 will give you back the 6. Done. Now I can see clearly that this is my A, m to the power of 3. This is my B, 3n squared. Just use these to evaluate it. So I know that the answer of this property is what? A plus B times. Always write down the property before you start. Okay? And then substitute. That's your A, that's my B. Okay? The A is m, so m to the power of 3 plus the B is 3n squared. Just write them down. And then the second bracket, you have to do some extra steps. So here you have to do, the a is m cubed, so you have m to the power of 3 to the power of 2, because it should be squared, minus a times b, so m to the power of 3 times the b, it's 3n squared, plus b squared, which is 3n squared. This is my b. I want it squared again. Done. Just simplify this. 2 times 3 is 6, so I have it as m to the power of 6 minus. How do you multiply? Just put the variables down and write down the number. I don't have any number to multiply the 3 with, so it's going to be only 3 n squared m to the power of 3. That's it. No need to multiply the variables, just put them down. Plus, and you don't need to change the powers. Here, 2 squared the 3, 2 squared n squared. So 3 squared is 9. N squared is basically n to the power of 4. If this is confusing for you, just take it on the side. This is the thing that I want to evaluate. Multiply it by itself. 3n squared times 3n squared. 3 times 3 is 9. N to the power of 2 times n to the power of 2 is n to the power of 4. Okay. M cubed plus 3n squared. Please take breaks while you are watching the video. It's going to be a very long video. I believe you need to take breaks. Okay. Again, for these properties, you have to practice. Just solving 2-3 questions is not enough. You need to seriously practice, and practice like on all different types of questions. Okay. So you have so far here you have 2 properties, and the previous idea we have 1, 2, 3 properties. So in all we have 5 properties. Okay. Now let's go into idea number 3, which is Pascal's triangle. I'll try to do something throughout the video to divide the video on while you are watching into like parts, and you can go to any of the ideas. If you just want to practice Pascal triangle, you can just skip and watch the part with Pascal triangle and so on. Okay, for Pascal triangle, you need to memorize how to draw your Pascal triangle, because we're not gonna give it to you in the test. How do we start? We start with 3 ones, and then these 3 ones by default, you have to start with them. 1 here and 2 ones under it, and then add these is gonna give you 2, and put 2 ones next to it. Then add each. Add these is gonna be 3. Add these is gonna be 3. Put extra ones next to it. Then add these is gonna be 4. Add these is gonna be 6. Add these is gonna be also 4. Put 1 before and 1 after, and so on. Okay. Time. How does it work? Basically, first of all, you have to know that if once you have number 2, this row is the coefficient of power of 2. This is the coefficients when you have power of 3. I'm going to explain in a minute what does it mean. These are coefficients of power of 4 because I have number 4. Basically, they don't matter. This is power of 1 and I don't really use it, and this is power of 0 and we also don't really use it. How does it work? Every single time you want to, let's say, expand this one, 2 terms, power of 3. How does it work? When you have a term plus another term and you have your power is number 3, you basically take the coefficient of the power that you have. My power is 3, so I take these coefficients, write them down. 1, 3, 3, 1. And then, only with Pascal triangle, the first term, you take it with its sign, so it's only A. The second term, you take it with its sign, it's positive B. Okay? And what do? For the first term, you take A only, will take the highest power. B will have no power here. Second term, A will have a lower power, and B will have a power to complete it to 3. So if this is 2, I need here 1, so they are 3 in all. And then if a will have a power of 1, b will have a power to complete to 3, 2. So as you can see, the a is decreasing, the b is increasing. Eventually you're going to have b to the power of 3 only, there is no a. Okay? And there's a very nice hack that you can use. You can just write down the first one, the second one, and the powers with the first term starts the highest, second term starts the lowest, and then this one decreases, this one increases. So starts 3, then goes 2, 1, back to 0. Starts 0, goes 1, 2, reaching 3. So as you can see, this is the starting, this is the end, last term. So I started with a power of 3, then a power of 2, then a power of 1, then there is no a. I started with no b, then b to the power of 1, then b to the power of 2, then b to the power of 3. And you can see the coefficients. From where did I get them? From Pascal's triangle. So the powers are increasing for the first term, decreasing for the second term, and make sure that it's the first term. The coefficients, we get them from Pascal triangle. And this is how you expand. Done. So how do we write down the answer? A cubed plus 3ab, a squared. B is power of 1, which is b only, plus 3ab, a power of 1, so just leave it, b squared, plus b cubed. 1 times b cubed is b cubed. That's it. This is the answer. Let's try to do that on x and y. So let's do the same procedure. First of all, know your powers, create your power table, and use the coefficients from Pascal triangle. So my power is power of, let's take power of 4. So create your power table. I have the first term is x, the second term is y, positive. So both of them are positive basically. I start with the first term, highest power, then decreases, 1, and then disappears. Second term starts with 0, then increases. Okay? This is start, this is end. And then what do? Just put down your coefficients. Which coefficient I use? Since it's power of 4, I use the coefficients with the number 4. Okay? So I'm going to use these coefficients. Remember, number of coefficients is 1 more than the power. If it's power of 4, then I have 5 coefficients. 1, 2, 3, 4, 5. Okay? So the first coefficient is 1. Second one is positive 4. Next one is positive 6. Next one is positive 4. It's just like a game. And then first term, what are the terms I have? X and y. So x will have power of 4 and y will not be there. So only x to the power of 4. Second one, I will have both. X power of 3, y power of 1. As you can see, x power of 4, then no y. X power of 3, y to the power of 1. And then x power of 2, y to the power of 2. Every single term, the x and y, they add to 4. X and y, they add to 4. X alone, it gave me 4. Here, next one, x to the power of 1, y to the power of 3. So, last one, I don't have an x, only y to the power of 4. And then just simplify. So, it's going to be x to the power of 4 plus 4 times x to the power of 3y plus 6 times x squared, y squared, plus 4 times xy cubed plus y to the power of 4. That's it. Later on, you might not have x and y. You might have x and the number. So suppose you have x not, let's take plus 3, for example. Power of 5. How does it work? Again, power of 5 means you need the row that starts with number 5. So this is not the row I'm working on. You have to create one more row. So 1 plus 4. Again, how do we do Pascal triangle? I will revise with you from the scratch. Pascal triangle starts with 3 ones. They are just they don't matter. You just have to start with them. And then add the ones. It's going to give you 2. Put ones before and after. Add these 3. Add these 3. Put ones before and after. Every 2 together, add them. Ones before and after. 5, 10, 10, 5, put ones before and after. 6, 15, 20, 15, 6, put ones and so on. Since it's power of 5, then I can clearly see that these are the coefficients I want. Okay, there are 6 coefficients, 1, 2, 3, 4, 5, 6. Remember, the power is 5, then how many terms? 6 terms, one more term than usual, okay? Then the power. So how does it work? First of all, put your coefficients. It's 1, then positive 5, then positive 10, then positive 10, then positive 5, then positive 1. And then what do? You create your power table. So on the side, create a power table. How does it work? Just create a table with your terms. My terms are x positive and 3 positive. Since the highest power is 5, then the x will start with 5, then 4, 3, 2, 1, 0. The 3 will start with 0, then 1, 2, 3, 4, 5. Okay? How does it work? This is the start, this is the end. So the first term will have the x as power of 5, and there is no other term. Second term will have x to the power of 4, and the 3 will have power of 1. So just use 3, put power of 1. Next term will have x power of 3, while the other term power of 2. So x to the power of 3, and the other term, which is positive 3, to the power of 2. Just use the sign of it always. And then we have, if it was positive, you don't need, because positive doesn't matter. But if it was negative, it will affect. Then we have the next term, we have power of 2, power of 3. So the x will be power of 2. The 3 will be power of 3. Make sure every single time they add to 5. And then we have x power of 1, 3 power of 4. And lastly, only 3 to the power of 5. Okay? Type. How does it work? Simplify. This is easy, just x to the power of 5. Now here, in the calculator, just write down 5 times 3 to the power of 1. It's gonna be 15. X, always use brackets, okay? Power of 4. Plus, here in the calculator, 10 times 3 to the power of 2. Use brackets, please, okay? It's gonna be 90. X to the power of 3. Then, you're gonna have 270, I'm not sure. So use here, it's gonna be 10 times 3 to the power of 3. Use the signs and use the brackets. Make sure to just be careful with the brackets and signs. So 10 times 3 to the power of 3 is basically 270 x squared. Just put the variable at last. And then here we have 5 times, multiply always the numbers together, positive 3 to the power of 4. So just put that in the calculator. It's going to be 405 positive. Put the variable x. And lastly, we don't have an x. We only have 3 to the power of 5. So evaluate how much is this. 3 to the power of 5 is basically 243. And we are done. This is the answer of this binomial. Okay, so this is how we do it. Let's take, for example, this case. This might be the most complicated possible way of having a question. First of all, you have to write down your Pascal triangle. Start with 3 ones, and then add these, put ones before and after. Add these, put ones before and after. Add these, and these, put ones before and after. I know it's power of 4, so I just need this row. So I can stop here. Okay, how do I know? It's just usually the row that starts with number 4. Okay, and also one more thing, if the power is number 4, then number of terms should be 5. So count them, 1, 2, 3, 4, 5. So this is for power of 4. So first of all, I start by writing my coefficients. 1, positive 4, positive 6, positive 4, positive 1. And then what do? Create your xy table, the like first term, second term. My first term is positive x, my second term is negative 2y. You will see that the negative will change a lot. And then the power, the highest power is 4, so I will give it to the first term and it will decrease. Second term will start with 0, increasing to the highest power. Okay? So the start will be the first term power of 4, so x power of 4. Then 3 and 1, so x power of 3. And the second term, it's negative 2y, all of it power of 1. So make sure to use brackets. Then we have x power of 2, the second term power of 2. So x power of 2, and the second term negative 2y, all of it power of 2. So see, this is a very important point to pay attention at. Then here we have power of 1 power of 3. So we're going to have x power of 1, then negative 2y, all of it power of 3. And lastly, we only have negative 2y power of 4. Okay? How do we evaluate? Before you put the numbers in the calculator, distribute the powers for the variables. So here we have x to the power of 4 only, plus. Keep the numbers, like just try to multiply them in the calculator. So I have here 4 only. Just do the numbers aside. So I have only 4 times negative 2, and the power of it is 1. Okay? So if you put this in the calculator, you're gonna get negative 8. So flip the sign from positive to negative directly, and write down the 8. Khalas, I'm done with the numbers. Now looking at the variables, I have x to the power of 3, y to the power of 1, which is y only. This is how we do it. Take the numbers aside, evaluate, and then put the variables. Same here. I have 6 times negative 2, but just check this, the power. It does have a power, which is power of 2. Put this whole thing in the calculator. You're gonna get, and make sure to use a bracket for the negative, please. You will get 24. Yes. So you're gonna get positive answer. And then now put the variables. I have x squared, and the y is also squared. Okay? Then don't rush into putting a sign. Finish the numbers. So I have 4 times, the number is negative 2, but it does have a power of 3. So put that whole thing in the calculator. So 4 times, please put the negative in the bracket so you can, once you cube it, it will give you a negative answer. If you do not put the negative in the bracket, it will change the signs. So please, negative 32, I'm done with the numbers. X has a power of 1, so it's only x. Y does have a power of 3. Lastly, how do we do that? Just do 1 times negative 2 to the power of 4, which is, just do this one. You're gonna get, I think, 8. Yes, 16. So it's positive 16, and the y does have a power of 4. That's it. This is how you do it. So evaluate the numbers first. I want to say something, just a note. If you want to double check your answer, once you have subtraction, the terms will start positive, then will be negative, positive, negative, positive. Okay? But as you can see here, if you have addition, everything will be positive, no matter what. So this is another way to double check your answer. Okay? We're done with all ideas so far. The only thing I want to discuss is the binomial theorem. I'm gonna cover this in class, or maybe in a separate video, because I need to show you on the calculator how to get the coefficients without Pascal triangle. You can use specific function in the calculator to do that, but it does the same thing as the Pascal triangle. in the exam we will just give you the choice to either use binomial theorem or Pascal triangle as you like, but I'm going to teach you both ways. You know what, I'll do this question before I end the video. So this is a different type of question. Maybe we did not do that before. Something similar to this. Type, let's do this one. I'll make it a negative, so this can be a bit more challenging. First, I'll do it with Pascal triangle. So I'll start constructing my Pascal triangle with the 3 ones. Okay. And then add these, you're gonna get 2. Put 1 before, 1 after. Add, 1 before, 1 after. Add, before and after. Add, and add these after and before. That's it. Power of 5, so I want this one. Okay, because it starts with 5 and there are 6 terms. Okay, so how do we do that? Just put down your coefficients. 1, positive 5, positive 10, positive 10, positive 5, positive 1. Okay, and then what do we do? This is my first term, this is my second term, it's negative 3. So create your powers table. My first term is s squared, my second term is negative 3. The highest power is 5, then decreases. The other one starts with the 0 to 5. Okay, fine. This is the beginning, that's the last term. Okay, so at first s to the power of 2 will have a power of 5. So this is how we do it. S to the power of 2, that's my term. Just put a power of 5. Okay, don't worry about it. Use a bracket always, always, always. Just my term is s squared. خلاص. So I'm gonna power it up again. Second one, and the negative 3 doesn't have a power. Second one, s to the power of 2 will have a power of 4. The negative 3 will have a power of 1. Always use brackets for your term. So later on I have 2 terms, s squared and negative 3. S squared will have power of 3 and then power of 2. Then s squared, negative 3. Power of 2, power of 3. Then s squared, negative 3. Power of 1, power of 4. And lastly, I don't have s squared. خلاص, I only have negative 3 and the power is 5. Okay, now how do we simplify? Do the numbers aside and the variables aside. If you have a variable with double power, just multiply the powers. So 2 times 5 is 10. That's going to be s to the power of 10. That's it. This is the only hack you have to know. What about here? Look at the numbers. I only have 5 times negative 3 to the power of 1. Put this in the calculator, you will get negative 15. Done. And what about the variable? It's not now s squared. It's squared times 4. So 2 times 4 is 8. S to the power of 8. This is how you do it. Done. And then here also 10 times what number I have? Negative 3 to the power of 2. Put this in the calculator with the sign, with the bracket, with everything. You will get 90, positive 90. Done. But here I have s squared to the power of 3. So 3 times 2 is 6. S to the power of 6. That's it. So this is how you evaluate double power. Okay. Next one, I have 10 times negative 3 to the power of 3. Put this as it is in the calculator. You will get negative 270. Done. What about the variable? It's s squared squared. So 2 times 2 is 4. S to the power of 4. That's it. Here I have 5 times negative 3 to the power of 4. Put this as it is in the calculator. As you can see, I'm taking the numbers on the side to evaluate them separately. 5 times negative 3 to the power of 4. This is going to be positive 405. S to the power of 2 to the power of 1, just multiply them, it will stay as s to the power of 2. And lastly, we have negative 3 to the power of 5. So it's going to be what? Only negative 3 to the power of 5. Put this in the calculator. It's going to be negative 243. That's it. How do you confirm your answer? First of all, count how many terms. Power of 5, then I'm expecting 6 terms. 1, 2, 3, 4, 5, 6 terms. Good. And then check the sign. Because it's negative, it should be positive, negative, positive, negative, positive, negative. Always starts with positive and ends with like positive, negative, positive. Depends on how many terms. Okay? That's it. Please make sure to practice and make sure you clearly can identify which property you have to use. For example, here you have to use the a squared minus b squared. Here you have to use the a plus b all of it squared. Here you have to use the a minus b all of it squared. Here a minus b all of it squared, and so on. It should be clear for you which property you have to use. How to use polynomial identity to factor this one. Basically factor it to show them how does it work. This error, we did it before, the error analysis. The mistake was she needs to write the 16 as 2 times something, but she wrote it as 2 times 4. 2 times 4 is 8, it's not 16. But to get the 16, it should be 2 times 8. So instead of 4, it should be 8. That's her mistake. What else? This is just factor it so you can tell them what is the missing terms, what are the missing terms. Here you just need to use Pascal triangle to expand these. How many terms do you have here? If you have the power is n, then how many terms? If the power of 6, the terms is 6 plus 1, which is 7. If the power of 5, the terms is 5 plus 1, which is 6 terms. If the power is n, then it's gonna be n plus 1 terms. Just add 1 always. Okay, if I told you that you have 10 terms, what was the power? The power was 9, just take 1. So the powers is 1 less, the terms is 1 more. That's it. Find the 5th term, just expand and find the 5th term. For example, here, if I told you find the 4th term, after you're done with expanding, count. This is the first, this one is the second, third, this is the 4th term. So the 4th term is negative 27, 207, 70, sorry, s to the power 4. That's it. This is the 4th term. Time. I'm done with this lesson. I hope that, I think it's a very long video, but I hope that it covers all ideas. Please pause throughout the video, watch, try to do the questions yourself, and you have to practice yourself step by step. Make mistakes, no problem. Double check your answers and just practice until you are done with it. Good luck.